Deep dive, method receivers, and pointer indirection in Go. Summary. Key concepts. Value receivers. Operate on a copy of the struct. The original struct remains unchanged. Pointer receivers. Operate on the original struct via its memory address, enabling modifications. Automatic pointer indirection. Go automatically converts values to pointers or dereferences pointers when needed, simplifying method calls. Value receiver example. Calculating area. Overview. The area method is defined with a value receiver, meaning it works on a copy of the struct. It calculates the area of the rectangle with height without modifying the original struct. How it works. 1. When the method is called, Go creates a copy of the rectangle. 2. The calculation is performed using the copied data, ensuring that the original struct remains unchanged. Key behavior. Any changes made to the fields of the rectangle inside the area method affect only the copy, not the original struct. This is ideal for read-only operations like calculating values or retrieving information. Output analysis. The calculated area is returned as 50. The original rectangle, width 5, height 10, remains unchanged, demonstrating the immutability of value receivers. Pointer receiver example. Scaling dimensions. Overview. The scale method is defined with a pointer receiver, meaning it operates on the original struct by accessing it through its memory address. It scales the rectangle's dimensions by a given factor. How it works. 1. The method directly modifies the width and height fields of the rectangle by multiplying them with the factor. 2. Go passes the address of the rectangle to the method, ensuring changes persist in the original struct. Key behavior. Since the method operates on the original struct, any modifications are reflected globally in the program. Pointer receivers are essential for mutable operations, where changes to the struct are required. Output analysis. After scaling the rectangle by a factor of 2, the dimensions update to width 10 and height 20. The struct is directly modified, demonstrating the power of pointer receivers for mutability. Combining value and pointer receivers. Overview. This scenario highlights how Go allows both value and pointer receivers to coexist within the same struct. It also showcases Go's automatic handling of values and pointers during method calls. How it works. 1. Value receiver, area. The method calculates the rectangle's area using a copy of the struct. Go automatically dereferences pointers when calling value receiver methods. Calling area on both a value, rect, and a pointer, and rect, produces the same result. 2. Pointer receiver, scale. The method modifies the original rectangle's dimensions directly. Go automatically converts values to pointers when calling pointer receiver methods. Both rect.scale2 and rect.scale3 update the original rectangle. Key behavior. Value receivers are consistent for read-only operations, ensuring immutability. Pointer receivers modify the struct, ensuring changes persist. Go's automatic indirection simplifies method calls, reducing verbosity. Output analysis. The area method consistently calculates the area as 50 without modifying the struct. The scale method successively doubles and triples the dimensions, resulting in a rectangle with width 30 and height 60. Deep dive takeaways. 1. Value receivers operate on a copy of the struct, suitable for read-only operations or small structs where copying is inexpensive. 2. Pointer receivers operate directly on the original struct, ideal for modifying methods or large structs to avoid performance overhead from copying. 3. Automatic indirection. Go automatically handles conversions between values and pointers during method calls. Value receiver methods can be called on pointers, automatic dereferencing. Pointer receiver methods can be called on values, automatic address of. 4. Flexibility. The combination of value and pointer receivers allows developers to design structs that support both immutable and mutable operations. By understanding and leveraging these mechanisms, Go developers can write efficient, maintainable, and idiomatic code that balances performance with simplicity.